Hello, I'm sorry for the long delay, but for today I really have a very interesting idea to discuss with you. And this is a unique feature of Postgres. First of all, let's prove the version of Postgres. You can see that this version is the most recent one available up to this moment. And also let me emphasize that this discovery is not only mine or based on public information. Also a good friend of mine, his name is Nog Tibor Levente, had an important contribution on this subject. Please remember this name, Nog Tibor Levente, because he might become an international recognized relational database management professional very soon, very soon. His activity is already noted and will be very important very soon. So we base all we discussed today on a table having very simple values, columns and rows, which will be set every time we move the test, and which comprises these values: IDs 7, 9, 15, 22 and 100, and values val 7, val 9, 15, 22 and 100. The subject we are going to discuss today is about common table expressions. In Postgres, you know that in the common table expressions you can put not only select statements as in Oracle or Microsoft SQL Server, but we can use update, delete, and insert. What's interesting, let's do the first test. What's interesting here is that if we do this, the update we just have issued is not visible. Yes, that's fine, that's normal, because as we know, at the beginning of a transaction, Postgres does a snapshot, and all the selects here will use that snapshot, except the values which are returned by this instruction, returning in update. So even if we did the change and the change was not visible in our test table in test schema, the modification was done. You might find this a little awkward, but it is not, because we do have the returning clause. And we also know how the snapshots are functioning in Postgres. Let's reset the data again. Okay, let's see. The data was reset. Okay, and now let's do a select which involves both the returning and the normal table. And you will see that yes, we can see the returned values, which are the actual values in fact. You see here, ID from returning, val from returning versus ID from table and val from table. Definitely returning will return only what we have changed, not all the rows. That's why we needed the left join, and that's why we can see here nulls. Okay, if we do the check from the table, we really see that the value for ID7 was changed. Okay, let's go back and reset the values. Let's try again and see that the values were the values from the beginning. Anyways, As the tests are going forward, we will change this value so that we cannot confuse it with the previous values. The interesting thing would be, what if we use more than one such kind of statement: insert, update, or delete. And today we will focus only on updates, because trying all the possible combinations would be much too much for such an example. But it would be enough for you to imagine what's happening. As we can see now, we are updating the ID7 row, the ID9 row, which are different rows, and we will see the modifications in the result set because we are doing two left joins. Indeed. Okay, let's hit the run command, and indeed the ID7 will get the value 2.1_7. The ID9 will get the value 2.1_9 value, and they are visible in this left join. Let's look at the table itself. Indeed, it is modified accordingly, but we cannot see this in the statement itself. Okay, let's go back, reset the values. Let's look at the fact that the values were reset. They were. And now let's look at what happens if we do the join in reverse order. First B and second A. That's the same. Nothing changed. Okay, that's good. And now it's 2.2. It's not anymore 2.1. So if we look into the table, we see that the things are the same. Let's reset the data again. Let's check the data was reset. Indeed it was. And now, what if we don't modify the different rows, but we modify the same row with A1 value and A2 value? Okay, this is doing a left join on B only. So if we do the modification and the join with B, we can see that we do have this. What about 3.1 A1 value? Nothing. It couldn't be visible here because we haven't used it in the left join. What if we look into the table? If we look into the table, the value does not appear. Interesting, right? Okay, let's reset the data again. The data was reset, and now let's do not the same thing, but change B to A. Change B to A. Okay, F5. Yes, this time we see that the value is the value corresponding to the A common expression. And the table itself contains A1, not A2. Well, interesting. Interesting enough. Let's go further and try to explain this a little better. Let's do both left joins, A and B, in this order. Now you can see that the value from A is returned, but the value from B is ignored. Levi and I, we have tested using also a trigger on the table, and the value which is missing here, 3.3 underscore A2, was not present even in the audit generated by the trigger. So somehow Postgres knows that we try to modify the same row 2 times and ignores one of the modifications. Which one? Let's go to the next test. So now the values are, as you can see. Let's reset these values. We did. Let's check. We did the reset, and please look at the fact that we have used the same select, except that we have changed the order of the left joins. Now A is not the first in the left join, but B is the first one. Hit F5. This time, uh, the value 3.4 underscore A1 was ignored and 3.4 underscore A2 was used. So it appears that the first invocation would prevail, and Postgres will do the modification generated by the first invocation and will ignore the other one. Would it be really true if this happens? Let's see further. So I have reset the values. Yes, we can see I have reset the values. And let's try to do something else instead of 2 left joins. Instead of 2 left joins, we will do a single left join, but we will unite the results using union all. And we will have an A and a B to mark the results. Hit F5. So yes, we can see here that the first one, the value of A, prevails while the value of B is ignored. Indeed, that's what we have in the table. Let's do the converse. I mean, use first the B and second the A in the union all. And let's execute again. Again, this time it seems consistent with the previous example that the first used result set prevails. We used B. You see, it's B here. I did a mistake, but putting A here, it should have been B. So the B value was actually here in the table. Let's reset the results. F5, F5. And now some tests that will involve the IDs 7, 9, and 9, 15. A first table that will involve only B for now. And yes, we can see that B is here. What do we have in the table? In the table we have 1 for A1, 2 for A2, but the common value was updated accordingly to A2, which is the first used, in fact, the single one used here. Let's reset the table. Let's go back. See, we have done this. Now we will use the first one doing the same update. Almost the same. Only this version here changes. F5. Yes, now we have A1 twice. A2 isn't here because we haven't used B. But in the table we have A1 for 7 and 9. But for 9, we don't have A2. We have A2 only for 15. which is again consistent with the idea of the one used, or the first one which was used, prevails. Let's do another test looking at both. Okay, so as we can see, the first one here was A, and A prevails for value 9, while B doesn't do anything about the common ID, it does only on the other ID. Let's reset. Let's see that the values were reset in the table and switch. We had A and B, we have B and A. F5. Again, B, because was invoked first, prevails, and the value 9 is retained for the second update, not for the first update, which was invoked a little later. I won't go further into details. The same happens with the left join and union all and whatever else we will do. I'll end the presentation here with a small conclusion. If you really need to have more statements in common table expression, please keep in mind that you won't see the values in the select unless you are using the returning clause, and please don't mix IDs, don't mix rows. It's much safer to have independent rows than base the results on the order in which you are going to use the common table expressions having returning in your select. And also don't forget, please, don't forget the name of my very good friend Nog Tibor Levente. You will heard about him in the next years. Thank you so much. See you next time. Bye.